The fundamental theorem of algebra basically says that the degree of the polynomial is going to match how many zeros you have. Complex meaning real and non-real. But some of them can be repeated, like that last example that we were just looking at. I would say there are 4 zeros here because 2 is repeated. This is the one that we were just doing from the homework. Agreed. So there are 4 zeros here. So this should end up being a 4th degree polynomial after I multiply it all out. So fundamental theorem of algebra just tells us that the degree and the number of zeros should match. And then there's also the complex conjugate theorem that says if you got a zero that's complex, then its conjugate is also a 0. So those are the 2 theorems. We wrote those down in our notes on Thursday last week. So we're going to use those today again, and then kind of combine them with what we did in 2.4. So here's our first example. Let's find all zeros and write a linear factorization. That would be the instructions. And function we're working with today is f of x equals x to the minus 4x to the plus 10x squared plus 12x minus 39. And one more piece of information just for fun. That's a 2. Oh, just trying to be a 2. I usually cross my z's. 2 plus 3i is a 0. So we've got a polynomial. I'm giving you one of the zeros. How many zeros are there altogether? 4th degree polynomial. There's got to be 4 zeros. And we know what one of them is. In fact, we know what 2 of them are based on the complex conjugates rule. Right? So let's go ahead and start writing this out. Our zeros, we know there are going to be 4 of them. And we were told one of them, 2 plus 3i. What's the other one that we automatically know? 2 minus 3i. And these other 2, what do we know about them? They exist. Good call. Are they real? Are they imaginary? Are they irrational? Are they irrational? I don't know. Here's a fun question for you. If they are rational, what are my choices? There's not very many of them for this one. Choices?
Pause. Both of my missed 1 or 39.
So you'd use the P over Q list. So 39, the Q list is 1, right? So there can't be any fractional ones. So factors of 39, there are a couple factors of 39. So 1, 2, 13, and 39, agreed? Or 1, 3, 13, and 39, thank you. So my possible real zeros would be 1 over 1, 3 over 1, 13 over 1, or 39 over 1, or the negative versions of all those. So we could graph it and see if any of those work out. Spoiler alert, they don't. Which means that these are either irrational or they're imaginary. So how are we going to get at them? Well, what did we do before when we knew what some of the zeros were? We used division, right? We took our original polynomial, we divided out the zeros that we knew were part of it. Now, have you ever done synthetic division with imaginaries before? It's possible, but it gets it's very messy. So I'm going to suggest that we don't do that. I'm going to suggest we do instead is let's write out the two factors that we know we've got, because that is part of what they asked us to do. They asked us to write a linear factorization. So we should be able to write a couple factors right now. X minus 2 minus 3i and x minus 2 plus 3i. I don't know what my last two factors are going to be yet. We'll soon find out. My suggestion is, why don't we go ahead and multiply these two things together? That's going to give me a polynomial of degree what? That'll give me a second degree polynomial. And then we could divide that up. We're going to have to use long division though instead this time. So I'm going to multiply these out. And let's see what we get here. So if we use our shortcut, for this, what's going to be our A and what's going to be our B? X minus 2 is going to be our A because that's the same in both. And then the coefficient on the I is going to be our B. So the 3 is going to be our B. So using the shortcut, when we multiply this out, we should get A squared plus B squared. A was X minus 2 and B was 3. And I don't know why I wrote squared here. That's not mark that. So let's simplify that a little bit. X minus 2 quantity squared. Are you guys feeling, did you get a chance to practice with these shortcuts a bunch in your homework? Were you very intentional about that practice? It's going to help you a ton. Square the first thing, square the last thing, multiply them together and double it. That's our X minus 2 squared. 3 squared is easy. 10, right? And then all together, x squared minus 4x plus 13. Why did I do this? Well, what I'm going to do next is I'm going to take my original polynomial and divide it by this. And I know I'm going to get a remainder of what? 0. Right? Because this is a factor because it came from two factors. I know I'm going to get a remainder of 0. And the other piece, the quotient, should be whatever these two factors are multiplied together. I'm going to divide this by this. That's going to give me this. Does that kind of make sense? Okay. Numerically, if I told you that the number 123,123 was divisible by 11, if I told you it was divisible by 11, how would you figure out what that other number is? You go 123,123 divided by 11, and the other piece that you got would be this, by the way. That is, I'm pretty sure that's true. Oh, battery low. That would be 11193. And then I could maybe use this to find some other factors, right? So we're going to kind of do the same thing. We know this is a factor, so we'll take our original thing, we'll divide it out and see what we have left over. And that'll help us figure out what these other two factors are. All right, we're going to have to use long division for this one. Thank goodness we've been practicing this since the beginning of the year. You guys got pretty good at this. All right, here's your chance. Show me your skills. Don't just copy my work, do it yourself. Get stuff have a look, but otherwise do it yourself. Hey, nice. Let's cancel. Oh boy, this is always super exciting when it works out like this. That was not so bad. Let's turn off one of these lights. You guys all right with that? All right, how are we doing? We're getting close. It's always nice when you get two columns to cancel out at the same step. Shortens your work. I'm hoping you got a remainder of 0. Did you get a remainder of 0? And x squared minus 3 for your new factor? Yep. I got x squared minus 3. Is that what you got? Oh, that's wonderful. I like that. That doesn't factor, but I don't need to use the quadratic formula to solve this. Right? So whatever I get when I set this equal to 0 and solve, that's going to give me my last two zeros. And then I can use those to find my factors. So this is going to give me the information I need for my last two zeros. And that came from here. So let's do that. I got a little bit of room off to the side, so I'm going to do it right here. X squared minus 3, set it equal to 0 and solve. That'll give you your two zeros that come from it. So plus 3 on both sides gets us x squared equals 3. Take a square root on both sides. Don't forget your whole little plus or minus thing. There's our last two zeros. Root 3 and negative root 3. Which means my last two linear factors would be x minus root 3 and x plus root 3. And we're done. What do you suppose I would have had to do if this didn't come out to be something I could set equal to 0 and solve like this? If it was a trinomial like x squared minus 3x plus 1, what do you think then? That thing? The thing with the song? What's he looking for? Oh, close. It's a formula. Quadratic formula. Yeah, we have to do the quadratic formula. Which you'll see some problems like this in the homework where you'll actually have to do the quadratic formula when you get done with this stuff. All right, we feeling okay about this? By the way, so they asked us in these instructions to write a linear factorization. I want to write what our answer would be if instead they had asked for a product of linear and irreducible factors. Product of linear and irreducible. I think they actually include the word quadratic. So when they ask for this, they're asking for, they don't want to see anything with i's and square roots in our factors. So if they're asking for linear and irreducible quadratic factors, these don't count as linear factors. And these don't either. So instead of writing these two factors down, I would need to write the quadratic factor that they came from down. And instead of writing these two factors down, I would need to write the quadratic that they came from down. This would be our answer right here. So if they asked us for for this version of the answer, it would be f of x equals one factor would be x squared minus 4x plus 13. And the other factor would be x squared minus 3. Those are irreducible quadratic factors. Irreducible kind of meaning they can't be factored any further. Not without creating factors that have complex numbers and irrational values in them. So we're going to do this again for one more problem. That's it. We'll be done with our notes for today. You guys should have a decent chunk of time to start on homework and check your previous homework assignments. One more, but it's going to be a long one. Buckle up. So this is going to be kind of like what we were practicing in like 49 through 53 in section 2.4. So you did one of these in your homework last night, hopefully 53 or 54. I can't remember. One of those. So same instructions. We're going to find our zeros. We're going to find our factorization. We'll write our factorization both ways again. Let me get you our original function. F of x equals this time 4x to the 4th minus 25x cubed plus 62x squared minus 74x plus 15. So same instructions, basically factor it and find all your zeros. No extra information this time though. So I'm not giving you hints about what things are factors of this. We got to find them all on our own. Dun, dun, dun. We got this stuff. So where shall we begin? All on our own. I should say all on our own using only our brains, our paper, and our graphing calculators. No Wolfram. That would be the easy way. Anybody been messing around with Wolfram Alpha? Have you used that to check your work on any of these? Okay, that's fine. I'm not trying to advertise them or anything. I don't know. Did I tell you guys about his TED Talk? He's got a very interesting TED Talk. Sorry, small commercial break. So I don't know how I feel about this Stephen Wolfram guy. He invented Mathematica. He's like incredibly smart. So I watched his TED Talk. This from like 12 years ago, and he was talking about Wolfram also and kind of plugging it. And he's got an interesting philosophy on education. He thinks that the stuff we do in our classes is just complete nonsense and a waste of students' time. And which I don't agree with him on that. But he says that his goal back at the time, it doesn't work yet, but he wanted to make Wolfram Alpha into something that you could feed in. For example, you could say, I would like an 11th grade level term paper on the Cold War. I'd like it to be 6 pages long. I would like it to have 7 reference sources in this source format, with a rate of like 2.5 spelling or grammatical errors per page. And it would generate a completely unique term paper on whatever subject that you put in. That would be like, if you ran it through like one of those plagiarism things, it would never come up, because like 2 people could put in the same parameters and get 2 different things out of it. Yeah, so basically I want to be able to write a computer program that can do all of this stuff for you. What do you guys think about that? Is that a good idea? You could just cheat your way through English then, just the same way you can cheat your way through math, right? You already do that with math, right? With photo math. So, and then he proceeded to explain why he thought this was a good idea. And all if you're interested, it's a TED talk from like 12 years ago. Maybe I'll put a link on Canvas. He's kind of full of himself. That would be my guess. And so he's like the alpha, you know. I don't know. That would be my guess. I have no idea. All right. So what are we gonna do? I got spoiler alert. My calculator's already out. So starting a calculator, graph it. We'll keep our fingers crossed and hope we see some nice x-intercepts, right? How many zeros are we expecting? Are we going to see 4 x-intercepts necessarily? No, because it's possible that some of them could be imaginary and we don't get x-intercepts from imaginary zeros. But I can tell you that I see either no x-intercepts or 2 x-intercepts, right? Because if there are imaginaries, they're going to come in pairs. Why is that washing out so badly? Oh, there we go. There's 2 x-intercepts. Hey, one of those looks nice. I got a strong feeling about 3. What do you think? Are you confident you know how to verify whether 3 is indeed a 0? Quick way to do that. Second calc value, type in 3. Hope your calculator spits back a 0 at you. Hey, nice. 3 is without a doubt a 0. Because when I plug 3 into my function, we get 0 out of it. So we got 3. 1 down, 3 to go. Looks like we got another real 0 here, somewhere between 0 and 1. So let's think through our P over Q list. Our P list would be factors of 15. 1, 3, 5, and 15. Our Q list would be factors of 4. 1, 2, and 4. What are the possibilities if we really only care about things between 0 and 1? 1/2, 1/4. 3/4 could potentially work. It doesn't look like it is 3/4. If I had to guess, I'd guess it's 1/4 based on where it is. But if it's anything that's rational, it's in this list, right? Because everything else, can anything else fall between 0 and 1? No, everything else would be bigger than 1 or negative. So if I had to guess, this looks like doesn't look like it's a half. Definitely doesn't look like 3/4. Let's try a 1/4. Oh, here we go. Please work. Hey. So 1/4 works. That's great. We got 2 of them. And then what do we know for sure about the last 2? You're gonna be imaginary. Because they're not showing up on the graph, right? So they're gonna have to be imaginary. Which means the only way we're gonna get to them is to divide this down so we get it to a quadratic, and then if we can solve it like that last one, that would be great. Otherwise, we're gonna have to use the quadratic formula. This time around, since we've got some nice factors here, we can go ahead and use the synthetic division. So that's what I'm going to do. I'm going to start with the 3. Start dividing down my polynomial. And we should be able to divide the 3 out and then the 1/4 out. That should just get us down to a second degree. So folks, are we getting comfortable with the idea that every time we divide out a 0, we're coming up with a slightly smaller polynomial? And that makes sense, right? Because if you pull 1 0 out, the number of zeros is related to the degree. So if I pull a 0 out, then the degree should go down by 1. So I know 3 is a 0. I know this is going to be a 0 for my remainder, but it's going to do it. If not, it means I made a mistake. No, that's I have to make some notes here. That 3 came from the 1/4 list. Did we come up with the same things?
Yep.
So what I've done so far is I've divided out the factor x minus 3 and x minus 1/4. I'm trying to decide whether to divide these things by 4 or not. Looking at my original function and checking the coefficient. The original function has a coefficient of 4 in the front. I think I want my third factor here. I think I want this to have the 4. Do you see why? Because x times this would be 4x squared minus 12x plus 20. That would give me the 4x to the 4th that I'm looking for in the original function, which I can't show on the screen here. But if you look up at the top of your own problem and scroll up, right, we've got to have a coefficient of 4 out front. So somehow I've got a 4. I got to have a 4. I guess the other way I could do it is x minus 1/4. What's another factor that would have a 0 of positive 1/4? 4x minus 1 would also have a 0 of positive 1/4, right? And in this case, then I would want to go ahead and divide all of these things by 4. So that would be x squared minus 3x plus 5. My students often get a little bit weary at this part, like, how are those two things the same? Come up with them. Ask me some questions here if you need to. So are you okay with how this would also have the same? I divided out a 0 of 1/4, right? When I did this synthetic division, this also has a 0 of 1/4, right? If I set it equal to 0 and solved, I would get 1/4. So if I think about what do I do to get from from that factor, that factor. I'm changing it. I'm multiplying times 4, agreed? So to keep everything kind of balanced, then I took this factor and I divided everything by 4. That way I'm multiplying one of my factors by 4 and dividing my other one by 4, but that should kind of cancel each other out. That's one way to think of it. They're both right. So neither is better than the other one. Question. Just so you can leave it like this. The thing you definitely want to do is double check. We're expecting to get a 4x4 as my lead coefficient, right? If I multiply out all my lead terms, x times 4x squared, that is going to give me 4x to the fourth, or x times 4x times x to the second, that's going to give me x to the fourth also. So as long as you're getting that correct lead coefficient, doesn't matter which way you do it. The other way you should be able to, the other thing you should be able to check is your last term, this 15. If I multiply out all my constants, I should get 15. So -3 times -1/4 is -3, or +3/4 times 20 is 15. It does work. I'm stumbling over my words, but it does work. -3 times -1 is 3 times 5 is 15. That works also. All right, we're not quite done because we don't have our last two zeros here. They're both going to come from this or this. It doesn't really matter. It's the same thing. Just one's been multiplied by 4. So take whichever one looks nicer to you, set it equal to 0 and solve. I'm going to go with the one that's smaller. But if you had chosen the other one, right? If you had chosen the other one, convince yourself that you're just one step of algebra away from turning it into mine, right? Divide by 4 on both sides of the equation, and you will get the other one. Anytime you're about to do the quadratic formula, you always want to check and see if you can divide everything, right? Because the quadratic formula is messy enough, you might as well deal with the smallest numbers possible. So yeah, this doesn't factor, so now it's time for good old quadratic formula. So time to plug and chug. What's to be plus or minus b squared minus 4ac over 2a. And we've got B, D, A, C, and A. Okay, I'm going to get a negative under my radical. That drives with what we were talking about a second ago, though, right? We said we were going to have imaginary answers for this one. Formulating these complex zeros, I want you to get in the habit of having the I part and then some kind of coefficients in front of it. So rather than including that I in the fraction with the radical 11 and the 2, pulling it off to the side. So we can now write out our linear factorization. I'm going to go with the x minus 1/4 this time. And then both of these, use your opposite sign. So x, that was a positive, so I'll go -3 halves. Positives turns into negative, root 11 over 2i x. When we write out factors like this, we don't use plus or minus. So you need to write out both factors. That would be my linear factorization, but there's something wrong with that. No, it's irrational and imaginary. What's wrong? What's wrong with it? What do I need to throw out? I lost my 4 someplace. Couple ways that I could fix that. I could multiply any of these factors by 4, or I could just stick a 4 in front of the whole thing. But remember back in the original function, we were supposed to have 4x to the 4th. And without this 4 here, I've got x times x times x times x. I got 1x to the 4th. It's supposed to be 4x to the 4th, so I'm missing a factor of 4 someplace. So I'm just going to put it in front this time. But just know this and be aware of this as you're doing your homework. If you look at it, if you do an odd numbered problem, you look in the back of the textbook, you're like, oh, they've got a factor that's different than mine. If they wrote this as 4x minus 1 and you wrote it as x minus 1/4, it's the same thing, right? It's still going to give you the right 0. Just look and see, do they have a 4 someplace else? So there are going to be multiple correct answers. Oh, I got to do one more thing. I left a couple blanks up top of my page. My last couple zeros, let me just write these in here for completion. We came up with 3/2 plus root 11 over 2i and 3/2 minus root 11 over 2i. So we're basically doing the same thing that we did last week, all last week, right? It's kind of a big, long, messy process, but I think it's satisfying. Process is, what do we do first? What's always our first stop? P over Q. I usually go to something else before my P over Q because we might not need the P over Q. What? Yeah, so graph it first. You never know. You get a 4th degree polynomial and you look and you got 4 x-intercepts that are like all integers. Boom, you're done with the problem at that point. And there might be one like that on your test. There usually is. All right, so graph it first. Look and see what you can see from the graph. Usually there will at least be one that you can find on the graph, and then maybe another one that you can find with your P over Q list. So we had this one that was kind of a betweener. So somewhere between 0 and 1 we could see from our graph. So we generated our P over Q list and looked for potential winners between 0 and 1. And we found one that worked. Once you've exhausted everything, then basically you're going to divide. If you can use synthetic division, we looked at an example today where synthetic division really wasn't going to work because 2 of the zeros that we got, this time not from a graph, but from a given, were not real numbers. So we ended up having to do long division instead. But the idea is divide out the stuff that you got to make your polynomial smaller. Once you get it down to a nice bite-sized polynomial, it's usually going to be 2nd degree, then you're going to go for your quadratic formula. Or sometimes you'll get lucky and be able to solve without it like we did right here in that first example. All right, so that's the gist of it. And again, that's about half of what you guys are going to see, about a third of what you guys are going to see on your test. We're getting to the 2-week warning point for our test. So our next chapter test is going to be in about 2 weeks. All right. Allow alarm. Yeah, I'll kind of pace everything out, see how we do. It kind of depends on how rational functions goes in our next lesson, whether we can get that done in one class or whether we can just split that up. But we'll kind of see as we're doing that. All right. I don't have the homework up on Canvas yet. I got to do that still. So let me write it up here. So give me a second.